Have you really been using operational and ensemble data the wrong way all this time? Well, the chances are you probably have, and I'm going to show you why. A new episode of Cold Rain's Weather World starts right now. Hi, folks, and welcome back to another exciting edition of Cold Rain's Weather World. I'm Jason Pritchard, your host, and today's episode is going to be centered around operational or deterministic models versus ensembles. You might ask, what's the difference? Well, I'm going to tell you about it. I'm going to tell you some of the ways that people misuse this information and also some ways that you should use it properly. Before we do that, don't forget to hit the like button, subscribe to the channel for additional videos, share on social media with friends, and make comments in the comments section. If you have any suggestions, if you have any questions about today's content or something else we've discussed, please don't hesitate to put those in the comments section. I'll do my best to answer those questions as they come in. So without any further ado, let's just dive into the video. So what is an operational or deterministic model? Well, this is a model that's constructed to predict what the atmosphere is going to look like anywhere from 12 hours to as much as 16 days. There are a lot of these products that exist. You've heard of some of those: the European model, the American model, the GFS, the Canadian model. And so the way this works is that the atmosphere is observed a couple of times a day, several times a day, through various means. Weather balloons are launched and they collect data from the surface all the way up through multiple layers of the atmosphere, data like temperature, pressure, wind speed, dew point. Satellite data is gathered, surface data is collected, and all of this data gets fed into these various deterministic models. These models go through their equations. They have atmospheric equations and physics, and based on physics and thermodynamics, and they come out with predictions of the atmosphere. And you've seen these charts flying around social media, no doubt. Height maps, wind maps, rain maps, snow maps. And a lot of this data just gets shared, and people don't really know what they're looking at or how to properly use it. And so what you sometimes see is a 10-day European snowfall map of 20 inches of snow over your house, and everybody starts to get excited and talk about it. Does that mean that there's a chance of a 20-inch snowstorm? Well, maybe, but probably not. So one of the things that we're going to look at today is, how do we know? So one of the things that we do to help us better understand the volatility of the atmosphere and the risk to any forecast that we're making is to look at ensemble data. So what is that? So the initial conditions that I mentioned before that get fed into the models are tweaked slightly and then fed back into the model, and the model reruns it, the output at a lower resolution. And that's done a number of times. So the tweaks are made, the models run, another tweak's made, the models run. And the point is just to see how volatile the atmosphere is to change, because we can't measure the whole entire atmosphere. We don't know what's going on between the points that we are measuring. And so the model guesses at that. And as you imagine, that compounds out over time. And so what we do is we tweak the initial conditions, rerun the model, and we do that a number of times. And then we see how much the output varies over the course of a day or two, as much as 2 weeks. And we understand, then we start to get a picture of how sensitive the atmosphere is to change. Is something going on between those initial conditions that's going to impact the atmosphere in a big way? And that can help us understand later on, is there a risk of a snowstorm? Does the pattern support it? And what does that look like? So the Europeans have a 51-member ensemble suite. So they rerun the data 50 times essentially. And Americans do it 29 times. And so, or 30 times rather. So we're going to look at, see how this comes together. But the ensemble data gives us a little bit better picture. It helps us to smooth out some of the error in the forecast down the line. What you're looking at here, we're going to start here. This gives you a really good illustration of what I'm talking about. This is called a spaghetti plot. And this is the 500 millibar height. And so as you can see here at 0, everything is matched up, all 30. This is the GFS ensemble suite, so we're seeing 30 members here in a spaghetti plot. And as we go out a little bit in time, you can see that the lines are tight together. There's not much error. The atmosphere is not all that volatile. We've tweaked the conditions, we rerun, and everything's kind of still together. So we're looking at about 24 hours out here. Once we start to get into the 2 to 3, 4 day time frame, we start to see some spread, particularly up here in the Pacific. So Still a general ridge here and a good agreement that over the next 4 or 5 days there's going to be a pretty zonal flow across the United States and so on. But if we come here and grab this and move it out a little bit further in time, we start to see really a lot of spread. We get out here to 126 hours. You've got a lot more in the way of spread. Now, we still see the general patterns. That's good. And we can have confidence that even at 126 hours, you're generally going to have a trough in the west and a little zonal flow across the eastern half of the country or for the rest of the country. But then what happens when we go out toward the end of the run? We're looking out here at 160 hours, 10 days out. The model runs to 16 days out, but you can see already at day 10, there's spread all over the place. The model is very unclear on what's going to happen. That would lead us to be unclear on what the pattern is going to look like in 10 days, which means if somebody's showing you a 10-day snowfall map, what are they showing you? They're showing you a pile of hot garbage, and you're getting fooled if you think that there's a snowstorm coming, because this map tells you nobody knows nothing. We go out here even further, look at that. It's just completely chaotic. So these models run 15, 16 days out. When you see a 384-hour snowstorm, you can just throw it in the trash bin. Not going to happen. All right, so that's one thing. That illustrates the point of uncertainty pretty good. But let's take a look at an example here when it comes to an actual snow event. So we're looking at a 10-day. Remember what I showed you, all those lines all over the place. But we're looking at a 10-day snow event here. So this is the European model 10-day snowfall map. You see some pretty decent snow here from Missouri all the way up into Ohio. A little bit of snowfall in Tennessee. Focus on Tennessee and North Carolina. You're seeing a little bit of snow right up there. GFS, operational model. You show another footprint of snow here that's sort of similar to the other footprint that we saw on the European map. People like to show this map, though. This is the one that you're going to see floating around on social media because it's got 12 inches of snow, 13, 11. You got all these pink colors. People love to see that. So they're going to post this and say, hey, it snow's coming. Let's flop over to the ensemble mean, and you can see the European ensemble mean. And, pretty good signal for snow here through the Ohio Valley, Tennessee. Look at this. You say, well, I have a winter storm coming. Well, you might. When did this, let's take a look at how this kind of evolves. So we'll look back, pretty much nothing here at 120. From 120, so basically from 5 to 8 days is where you see this really fill in. So that's where our snowstorm is occurring here, 5 to 8 days out. That's kind of an eternity where things can change. We know that, so just from our experience. So we're going to come back in here. Same with the GFS. You've still got a similar footprint. So far, you're looking at a potential snow event somewhere in the 5 to 8 day time frame. But does this really tell us what is the risk of that? What's the probability of that? It really doesn't. It just shows that both ensemble suites are seeing something. And honestly, when you're looking at ensembles, it's good to compare one suite to the other, because if you do see agreement, that would give you a little more confidence that potentially something's going to happen. But we're still 5 to 8 days out, so that's a red flag too. So the next thing I would do is not just look at an ensemble mean, is come in here and take a look at the actual individual members. So throughout 240, we're seeing, particularly around Tennessee, we're going to look at these members and see, do we have a signal for snow? And here's one that has some pretty good snow in northern half Tennessee. Here's one that's got a couple inches. Down here, we've got maybe an inch or so. Here's another one that's got some purple and blue. So, we're seeing a few hits here in the ensemble members. If you come in here and you see one big, and this is what you see a lot too. I'm rooting for P23. That's got the most snow over it. You'll see one in here sometimes. People post this and an individual ensemble member. Don't fall for that. That's 1 out of 50. That's showing a big snow skewing the whole mean. That's one of those things that you have on social media that you want to pay attention to and disregard that poster in terms of their credibility. But you come in here and you see a couple more hits in Tennessee. So, pretty good amount of hits. If we'll come in here and take a look at the next 25 members, remember there are 50 ensemble members that make up the actual European ensemble. And so we'll come in here and we'll see there's one that shows a little bit of snow. This one up here, P16, is pretty good, and so forth. Actually, I'm showing you the same Same panel as before. Let's do this. Let's look at 26 through 50. There we go. There's the other 25. So we'll come in here. Not much, not much, not much, not much, not much. So this suite doesn't have quite as many hits as the first 25. And so, yeah, so I mean, really at the end of the day here, we're looking at only about 40% of the members show any snow for Tennessee. So maybe, but between 5 and 8 days out with only 40% members here, I'm not sure. That's a great percentage. So don't buy the sleds just yet. GFS, kind of similar. You see a hit there. I look through these members and we're just, we're not seeing a lot of hits here. So while we've got some snow footprint on the ensemble means, we're really not seeing a lot of hits, and certainly no big hits in the GFS. So that's a red flag. So what you want to do when you see a snow footprint over your house, somebody's showing you this, you want to dig in and look at the ensemble members and see what they're showing too. But again, we're talking 5 to 8 days out here. So, what value is really in examining all of this too heavily? Not much. And if you're forecasting weather for an entity, or if you're on TV forecasting weather, you're probably not going to mention very much in the way of snowfall potential 5 days out with this kind of a signal. You'll see these probability maps posted too. I don't really like these maps because particularly when you get past 5, 6, 7 days, what kind of probability do you really, what does that even really mean? I saw a probability map of 6 inches of snowfall is like 70% here where I live. That was for 7 days out. There's no map in the world, there's no model in the world that can tell you have a 70% probability of 6 inches of snow in the Southeast for 7 days out. It's not possible. So it's sort of a misnomer to use this map to start to justify stuff. Use these kind of maps closer in and really get an understanding, because that's when the skill picks up for the model. This is just bogus. Okay, so don't fall for that. Same with the GFS. We've got, what is this, 40 to 50% probability at 10 days from now there's going to be an inch of snow on the ground. I don't think so. I've lived in the Southeast a long time. It might snow, but not because a probability map says it's going to snow. So the best way to use ensembles is to start at H5 and understand what the pattern looks like. So for example, we always talk about in weather, you want to look up to see down. The weather at the Earth is influenced by things that happen way up high in the atmosphere. And so that's where we want to look first. So really, before we should have done anything, if we saw a snow map on social media, the first thing we should have done is come in here and taken a look at the H5 pattern. The 500 millibar heights, where a lot of stuff happens, and you can start to see what's going on here. So you got the jet stream is going to flow like this. You got this big ridge over Alaska, this big trough here in the western United States. This is a negative PNA, very bad if you like snow in the east. And then you've got this other feature here. This is a 50-50 low. This is going to help funnel in cold air or lock confluence in to keep high pressure in the area so that you can kind of get some wedging down here. So if I look at this pattern, I'm thinking based on my experience, if there's going to be any winter weather in the Southeast, it's going to be more in the mixy variety Miller B ice storm kind of pattern. You got some good blocking here. And what does the GFS ensemble suite say? So the ensemble mean for the GFS looks exactly the same. Well, almost exactly the same. You've got the big ridge here, big trough in the east, 50-50 low. This is nice. Potentially could get something going winter weather-wise. The battle zone is going to be up in here in this area. So when we saw the snow footprint through the Ohio Valley, this is probably a good signal for that. So we can look at 2 ensemble suites that show very similar things out at 126 hours. That would give us confidence that is a period to watch. So while I might not advertise snow if I'm a meteorologist forecasting in Tennessee, I might start to introduce the possibility of something coming in during that period if I'm in the Ohio Valley, because the pattern supports it. So that's how we would use the ensemble data. Operational models, the deterministic models, it's higher resolution. So as we get into that 5-day period, we can start to really dig into the operational model and start to hone in on what's going on here. And so we'll go back to the European and we can kind of bring this back, and we don't see anything going on in 61 hours. But then you can start to look at things like surface temperature products. I'll look at the anomaly just to see. Um, so that's the 2 meter temperature knot. Let's look at 2 meter temperatures Celsius. There we go. So we can roll this out and start to see the temperature patterns. You get a little bit of a better confidence in these operational models as you get into that period. Now, we're at 105. Our snowstorm would be somewhere in here. So remember we saw the kind of the snow footprint down in here. Look where the 0Z line is. There it crashes in, so you're probably going to get some rain changing into snow. And then you want to look at things like 850. We'll come down here to upper air temperature, look at your 850 temperature, see if that supports snow. We've got, let's roll it back a little bit. So, between 5 and 8 days, it looks like the European is suggesting, hey, we've got 850s that sort of support snow in here. We've got other 2 meters. We don't have 850s that support snow down here. So again, I would be highly questioning any sort of snow maps that showed snow in this area. Just because it's on an ensemble mean does not mean that there is a higher credibility for snow. So understand that. But to get into 5 days, you start to use the operational models. You get down into a couple of days, you can start to look at the NAM and some of the short range models, and they'll give you a really good idea of the thermal profile of the atmosphere. And so you can understand now, hey, do we really have a snow threat, or is it more ice, or what? So I hope that helps a little bit understand the difference between ensembles and operational models and maybe how to use them. The bottom line is when you start to see 5 to 10 day or beyond snowfall images out on social media, it should raise a red flag in your mind, and you should start to think, okay, what is the real risk of that happening? Sometimes it's not the amount you should look at, it's the signal for the event. And so instead of looking at the amount of snow in here and saying, hey, I've got a 1 footer coming in, maybe look at the signal and say, this is the most likely area for there to actually be snow, where these pinks are. And then down here, we're on the edge of warming up. And up here, maybe we don't have enough precipitation. But all of this is going to change 5 to 8 days out. Just know that. Look at, use ensembles to discover the pattern, see if the pattern supports, and then as you get closer in, you can dig into the details, dig into the members, then start to use the operational models to flesh out the real details and the profiles of the atmosphere that the ensemble members themselves, which are at a lower resolution, may not see so well. So I hope that helps, and we'll look forward to seeing you back. Don't forget to hit the like button, leave a comment, and we'll talk to you soon. Take care.